Linear is the one that's always looking like y equals mx plus b. There's no power to x at all. It's just mx plus b, and sometimes there's no plus b, so you can just have mx, but it's just x without a power. This one is exponential. Anything raised, like the x is the one on the top, it's raised to the x, is exponential, and quadratic is anything squared. Right, so linear, the power of x is 1, quadratic, the power of x is 2, and then exponential, it's raised to the x. So this is going to be linear, exponential, quadratic.
And the equation for linear is y equals mx plus b, where m is your slope and plus b is your y-intercept.
This one is exponential because it's raised to the power. Equation for exponential looks like y equals a b raised to the x. And sometimes they even have like a number out there. So let me call it c plus c. B is your rate of growth or decay. And then a plus c is your y-intercept. Y equals ax squared plus bx plus c. A right here is the second difference divided by 2, and c is your y-intercept. All right, so how do you graph linear equation? So you'll remember you start with the y-intercept, which is negative 15. So we're going to assume negative 15 is right here. Just going to label it negative 15. And then you're going to rise 1 and run 4. So rise 1 and run 4. So somewhere over there. For exponential, you need to remember, just based on the things that you have, your y-intercept is where a plus c is. So that's a and that's c. So 2 plus negative 4 is negative 2. So it crosses at negative 2. Okay. Is this growth or decay? Because this is what it's saying, growth or decay. So it's a number smaller than 1, bigger than 0. So it's decay. All right. So if decay from left to right, it's going down. And your isotope, I didn't write it in here, so let me go ahead and write that. C by itself is your isotope.
This is a listening check. Put a box around isotope.
C by itself. So negative 4 is your isotope. So crosses a negative 2, your isotope flattens out at negative 4. So when you graph it, it's decay. So it's going like this, crossing at negative 2 and flattening out. For your quadratic, okay, so my y-intercept is 8. And is it a happy or sad face? So positive is happy, negative is unhappy. So it's positive, so it's a happy face that's going through C being 8. So somewhere up here, let's call this 8 right here. So listen, that's not necessarily the vertex. It might be doing this, or it might be on this side. So that crosses at 8, so it looks like it's on that side. Okay, so it's something like this.
The listening check, circle 8.
All right, let's talk about domain and range. We all know by now, domain. All right, for everything in Algebra 1, except for word problems, is going to be what? All real numbers. Range for linear only is also going to be all real numbers. For exponential, it's on this case, it's from the bottom, which is the isotope. So that's negative 4. Does it include it? No, because it doesn't touch. Open. To where? To the top of the graph here, forever, which is what? Infinity. Or you can write that at y is bigger, not equal to negative 4. For the quadratic, it's the bottom to the top, so you need to find the vertex. Second, calculate. And I'm going to go to my minimum. All right, I go to the left, so you follow that little X thing, right? To the left, press enter, and then I go over to the right. I press enter, and then I press enter again, and it's going to tell me the minimum is 2, 6. So this minimum right here is 2, 6. Another way I could find that is hit second table. This is probably faster. So I need to find, like, see right here, the y's become the same on either side. That's the vertex. So that was actually quick to find. So 2x. So you'll see if I go up 1, it's going to be 8. Oh, I can't go up 1. Oh, I can. There we go. That's going to be 8. The next number is going to be 10.5. So what you need to find is you find that number where it kind of changes over where the numbers are the same. It doesn't always work, but it is like a quick shortcut for you. So now that I know my vertex from the bottom of the graph, the y, right? So that's 6. So including 6, yes. 2 where? Where's the top? Infinity. Open because infinity is not a number. And how else can I write that? I can say y is greater than or equal to 6 because it includes it. Characteristics is like your slope is the number by x. So m is equal to 1 over 4. And your y-intercept is a number by itself. Your y-intercept is equal to negative 15. All right, some characteristics about exponentials from an equation, like what can I tell from this equation already? I can tell that it is decay. Why? Because this is a fraction between 0 and 1. So some characteristics is that I know that it's going to be decay because b is between 0 and 1. Okay, that's how I know that it is decay. I can also tell you what my isotope is, which is negative 4.
The listening check. Color in isotope.
And remember, it's a line, so it has to be equals. It can't just be a number. So it's y equals negative 4. And I can also tell you my y-intercept. And that's when you add these two numbers, which is going to give me negative 2. All right, what characteristics can I see from this equation here? I see right here, my y-intercept is 8. What else can I see? That my a is positive, which means it's a smiley face. So my graph looks like that. And I guess I can also say I ended up finding the vertex, so I can write that down. And my vertex is 2, 6. And because I know my vertex, I know my axis of symmetry, which is always this number equals. So x equals this number, 2. Remember, axis of symmetry is a line, not a point. All right, let's take a look at I've looked at going from an equation to a graph. I'm going to look at going from an equation to a table. Okay, so when you're going from an equation to a table, you're going to go y equals. All right, I'm just going to type in the equation. So this is 2x plus 6. That's the equation. To get a table, I go second, graph. And then I just put in the coordinates, right? So negative 1, 4, 0, 6, 1, 8, 2, 10. The other way you can do it is you can plug in numbers. So second quick, if I do 2 times what's x, and let me just give it a value. So let me say 2 times negative 1. So it's this first one, plus 6, and that's going to give me 4. So if you don't have the option to do second table, you can do it by hand. To find average rate of change, we've done this 1,000 times now. So it's going to be, go to your formula, average rate of change, next to it, write that down.
The listening check. Color in AROC.
Remember, you just rewrite the formula with what? Box minus box over box minus box. You label x1, x2. Put a box with that. That means I need to find y1 and y2. And put a box with that. So when x1 is 3, and I don't have 3 here, so I'm going to go back to my table. So second table, go down to 3, y is 12. Go to 5, go down to 5, y is 16. Plug in those numbers. Y2 is 16, y1 is 12, x2 is 5, x1 is 3. Put that in the calculator. 16 minus 12 is 4. 5 minus 3 is 2. Simplifies to 2. Okay. What characteristics about this can I tell? So from an equation, a linear equation, right? So from a linear equation, I can always grab the y-intercept, which is equal to 6, which is the plus b. And I can always grab the slope, which is right by the x. So slope, which is m, is equal to 2 in this case. All right, let's take a look at another exponential equation. And I know it's exponential because it's raised to the x, right? So how do I do that? I go y equals, I clear what I have. Then I punch this in, so -3 open parentheses, 2 close parentheses raised, use that, x, and then bring the arrow to the right, +8. Second table, and I get some values. Now I'm just gonna make sure that I include these, okay? So I'll start at 0 in case I need the x instead. All right, 0, 5, 1, 2, 2, -4, and if I'm just gonna write 3, 3, -16. Average rate of change formula says y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I want you to draw with boxes, minus box, over box, minus box. Label x1, x2 with a box. Find me y1 with a box, y2 with a box. So when x is 1, y is 2. When x is 3, y is -16. Then just put it in here. y2, y2, y1, x2, x1, -16 minus 2, -18. 3 minus 1, 2. Simplify that, -9. What characteristics can you tell me? You can always tell me B, which is that growth or decay? It is growth. So growth, B is greater than 1. All right, you can tell me the isotope. And remember, isotope is always a line, like going horizontally, so it's always going to be Y equals, and it's this number at the end, okay, just the number at the end, so 8. And you can tell me the y-intercept, which is going to be what crosses the y-axis, and that's always going to be this number plus this number, which is +5. All right, let's look at a quadratic example. -x squared minus 1. Okay, then you hit second table. And then I just want to include -1 and 2. So these values here. So it goes -1 is -2. 0 is -1. 1 is -2. But I'm just going to skip that one and go to 2. 2 is -5. Find average rate of change. Write down the formula. This is a listening check. Color in the formula. Draw my boxes. Label x1 box, x2 box. Find y1 box, y2 box. When x is -1, y is -2. When x is 2, y is -5. Plug those into the equation. So y2, y1, x2, x1. Okay, put that as you see it in the calculator. -5 minus -2. 2 minus -1. Put that whole thing in the calculator. -3 divided by 3. All right, some characteristics about quadratics from this equation. We know that it crosses, this is the y-intercept right there. It's -1. Is A positive or negative? It's negative. So if it were doing a graph, it would be a sad face. Vertex, and anytime I have the vertex, I can also get the axis of symmetry, which is this number x equals. Okay, so to get the vertex, I have it already here, right? To get the vertex, let me see if I can do it with the shortcut. I need to find the pattern, which is right there. See that? -2 on either side. So that means if I go up 1, I should see -5. Yep, if I go up again, I should see -10. Yeah. So the pattern is -2 on each side will be, this is the vertex, 0, -1. Which means my axis of symmetry is x equals that number, 0. Okay. Once again, if it wasn't so obvious, so it's a decimal, then you'd go second calculate. And you'd want to say calculate, it's a sad face, so it's a maximum. Press enter, go to the left, find my arrow. There's my little star. Go to the right, press enter again. Okay, and my maximum is, okay, so you see this right here? It says -1.7, but you see, because it says e to the -6, it means this number is very, 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 very close to 0. Okay, so whenever you see that, don't take these numbers if there's an e there. So pay attention at 0, -1. And that's pretty much it. So let's practice.